Là, par exemple, si je le change, on va faire un essai. Hein.
Ouais.
Je mets celui-là et je remets celui-là.
Ouais,
C'est
parfait.
bon? C'est bien celui-là?
Ouais,
Voilà.
c'est ça, ouais.
Bah voilà, super.
Câble.
Je l'ai en stock si jamais il y a un souci. Ok?
Ouais, d'accord. Très bien. Merci.
Bah, de rien. Bon, bah je vous laisse tranquille et ça va bientôt commencer.
Marche,
D'accord.
merci bien.
Donc on peut s'asseoir
Ouais,
parce
on peut.
qu'on fatigue debout là.
Bah oui, oui.
Je l'ai en stock si jamais il y a un souci. Ok?
Ouais, d'accord. Très bien. Merci.
Bah, de rien. Bon, bah je vous laisse tranquille et
On peut se téléporter d'une chaise à l'autre. C'est trop bien.
Ah ouais, fantastique. Téléporte d'une chaise à une autre.
En effet, c'est drôle.
Faut pas le faire sur un trop gros écran, je pense, que pour l'estomac. Ah mince, on a fait la même chose.
Ah.
Pas voir tout le monde en même temps autour de la table.
Ah, Noémie, tu es là, parfait. Je regarde juste, je croise avec les noms du panel.
Bah, il y a que moi et Marc. Hein.
Oh, oui. Et il manque. Alors j'ai que les noms de famille, mais il manque Mayer, González et Leiting.
Ouais. Sachant que le dernier, ce sera peut-être pas lui, mais un de ses collègues, parce qu'il avait une difficulté d'emploi du temps.
Ok, nous on peut faire la petite introduction concernant le programme de l'après-midi, et puis ensuite on va attendre c'est 15 hein, le démarrage.
Ouais.
juste j'en informe l'organisation, il vous manque González, Carlos González Val et Tobias Leiting, c'est ça?
Oui, et j'ai pas vu Silvia non plus.
Silvia Menato, ok, j'en informe l'organisation.
Ils sont perdus dans le Laval virtual.
Ouais.
In the middle of nowhere.
En fait, je les ai recherchés dans le monde, ils y sont pas, donc je me renseigne.
Ok. Ouais, bah, moi je vais les contacter par d'autres
Leur
moyens.
train n'est pas arrivé. Le
Ouais.
TGV n'est pas arrivé. Et vous êtes présent en même temps physiquement dans l'environnement physique de Laval Virtual?
Ça dépend qui, moi je suis chez moi.
Ah, toi tu es de chez toi, d'accord. Mais sinon,
Avec
il y en a
Olivier,
qui
on
sont
opère
dans la salle?
Alors, avec Olivier, nous, on gère les conférences depuis le LVC
Ouais,
et pour le visitorat, ça dépend.
d'accord.
En ce qui concerne le visitorat, il y a une partie des gens en présentiel physiquement dans l'espace Mayenne, mais ils
Ouais.
pourront pas interagir parce qu'il y a une grande latence entre ce qu'ils voient eux et la discussion.
Ah,
Et
d'accord.
ceux qui poseront des questions, ce sont ceux qui nous rejoignent virtuellement ici.
D'accord. D'accord. Donc en fait, il y a un décalage entre le physique et le virtuel.
Ouais, d'environ 30 secondes à 1 minute. Dans la journée.
Ouais.
Dans la journée.
Ah, quand même.
Oui,
30
oui,
secondes à 1 minute. Waouh, 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 waouh.
ouais, pour eux, c'est comme si une rediffusion depuis les postes caméra. Oui, il y a une
Ouais,
latence.
d'accord. Donc il vaudrait mieux qu'ils prennent leur ordinateur et qu'ils se connectent finalement.
Tout à fait.
D'accord. Ok. Donc là, ceux qui sont pénalisés, c'est ceux qui sont là en présence physique.
Tout à fait.
C'est intéressant, effectivement. Intéressant. C'est ça, les modes hybrides. Dans le mode hybride, en fait, tu sais jamais s'il y a le bon niveau d'interaction entre le virtuel et le physique.
Oui, je suis assez d'accord, c'est assez brouillon hein, pour l'instant.
Ouais. D'accord, d'accord.
Okay, so we will start with a short presentation regarding the schedule and the program for this afternoon. So first of all, let me take the control of the screen. Just 1 second. So first, we have a panel regarding Do It Together. So we have 6 persons presenting a discussion regarding the European project entitled Inedit. Then we will have a first paper entitled Extending OpenSG for Real-Time Synchronization in Immersive Environments in Disturbed Collaboration. Then we do have a second paper, designing a mixed reality extension for an educational board game on fractions. Then we do have another paper entitled Leveraging Augmented Reality to Support Context-Aware Tasks in Alignment with Business Processes. And finally, another panel regarding adaptive interaction in XR. So first of all, please do not touch the screen. Thanks. So first of all, some good practices. If you have any question, feel free to use the public or the private chat of the room. You can also raise your hand and ask your question directly to the speaker, but please keep your mic off during the presentation. Thank you very much. And And okay, so and that's all. For those attending the presentation in the physical conference center, we will see you at 6:30 for the official award ceremony. And now we are going to wait a few minutes, and we are waiting our speakers, and then we will start the first panel regarding concerning Do It Together and the European project Inedit. So how many people do we have here for the panel? I can see that Sylvain is here, Marc, and we're waiting for your colleagues. Do you have any news? Silvia is there.
Okay, so Silvia is here.
Okay, nice, good, perfect. Hi, Silvia.
Hello.
Please have a seat here. And so yeah, we have Silvia, Marc is here, Sylvain, and
We
we're
are
waiting
waiting for Carlos,
Carlos, yes.
Frederique, and Andrea.
And I can see some people arriving. I don't know if Juan,
Which screen can we use?
so you can use the screen here. Sorry, you probably missed the very first information, but no worries. You can use the screen and take the control here, and you can display your presentation. So you should be able to put
Okay.
the
So
link
it
of your
was
presentation. Yeah.
okay. I have everything.
Bottom right corner, I guess.
Yeah, I have everything. And copy and paste the links. Okay.
Nice. So you should have the control over the presentation and the screen. Please everybody avoid using your the arrows on your keyboard when looking at the presentation, because you will switch the presentation and it won't be easy for our speakers.
Okay, sorry, I'm not able to have the control of the slides.
So if you want to control the slides, you should use the full screen mode. You know, you can click on the icon on the top right corner, and then you should be able to control the presentation with the arrows on your keyboard.
Okay. Not sure to have it, but in any case, I have really few slides. But I have also other presentation for the other screen, just to show the references of the project and the speakers.
So you want to put some content on the screen here?
Yeah.
Also, yes, fine. So you can come here and take the control over this screen and change the content as you wish.
Okay. Sorry.
So 5 minutes left before the beginning of the talk and the discussion. So I think we are still waiting for 2 or 3 persons from your team, right?
I think Tobias and Frederique are missing.
Frederique, Carlos, and that will not be Tobias, but Andreas. So three
No
persons.
news from Tobias, but Carlos is in the VIP lounge, so we are trying to reach him.
Nice,
Okay.
thanks. Okay, so 1 person missing.
Andreas.
Okay, so I can see some content on the screens here and here. That's fine. Yeah.
No. Okay.
Okay, so Oliver is bringing Carlos, so we should be almost fine, I guess.
We have some news from Frederique Mayer.
Not on my
Okay,
side.
Carlos.
I don't know if the staff from Laval
You
Virtual.
can take a seat, Carlos.
Hi,
Okay.
Carlos.
How are you
Welcome
doing?
here. So you can come with me here near the front chairs here. You should be fine for your presentation.
Sure. I will set something around here.
Bonjour,
Okay, so good news. Tobias is in the campus, so
Great.
to be here within a minute.
We'll make it. Marc, would you like to come to the other side of the room with the other speakers?
Yeah, sure.
So Sylvain is there. And so who is leading the presentation today?
Silvia.
Me, and I will leave the floor to the other persons in the team.
Nice, sounds good.
I
So
see only Marc, but I hope also the other are here.
Marc is here, and we have Sylvain here, Carlos.
Okay.
And yeah, so we're still missing 2 persons, but we can wait few minutes and we can, begin the presentation. And if maybe they'll join. Andreas is there. He's coming to the boardroom, so I'm pretty sure we only miss 1 person.
Okay, I don't know why I always
Okay, Andreas, you can
the last slide, but in any case.
take a seat.
Hi, Andres. So as you
Hi.
can see, your team is here. You can come here near the big screen. Yes, perfect. Thanks. And where's
So is Frederique Mayer still missing? Have you some news from her?
Me, I don't have news from Frederique.
So Sylvia, up to you. You could begin the presentation. It's up to you, or we can wait a few minutes.
We can start, I think, because Frederique is supposed to discuss with us in 15 minutes, so maybe she arrives.
Okay, that's fine. So yeah, so I mean, let's start the presentation and the discussion, and she'll join the team during the presentation. Let's go. So please go on. Thank you.
Thank you. So thank you everyone for being here. I'm really glad we are so many, and I hope this session can be interesting and also motivating for you. My name is Silvia Menato, and I'm from the University of Applied Science of Southern Switzerland. And today I will animate this session because we are dealing with a project I'm involved from the beginning. And so the session is supposed to give you an overall view of the Do It Together approach. That is a core theme, a core topic of the NEDIT project, that is an open innovation ecosystem for Do It Together process project funded by, it is a project that is funded by the European Commission under the Horizon 2020 program, and it started. I think that I have a timer that moves the slides, because after a few seconds I have a switch of the slides, but sorry for that. So the project started at the end of 2019, and it's running halfway. We are 16 partners, 14 partners from all around Europe. As you can see from the map, we have 6 industrial companies, and the other are RTD centers and research institutions. So as the title of the project says, the core of the project is the Do It Together process. And we started a few years ago working together from the idea that we wanted to shortening the time between the creativity and product manufacturing. And we wanted also to foster the customer creativity in this process. So to do so, we decided to exploit some technological opportunities, such as interactive technologies, since we are here today, and especially virtual reality and artificial intelligence. And we also wanted to exploit the do-it-yourself movement that is typical from the of the Fab Labs. So we got. I'm really sorry for that. Okay, we got to the NEDIT project in the end, that is funded, and the main objective of the project is to democratize the access to the open design and open manufacturing, thanks to the creation of a do-it-together ecosystem. So what we want in the end is to be able to design global and produce local. In the project we have a furniture manufacturer that will help us to demonstrate this kind of concept. So when we are speaking about design, and later on you will see some presentation of applications, we are talking about the design of furniture in this specific context. Okay, to achieve this kind of goal, we studied how to transit from the do-it-yourself approach to the do-it-together approach, and this is the focus of today. So we arrived to, but is anybody moving the screen? We arrived to the do it together concept definition that will allow to integrate the concept of social ideation, of social open innovation, and social open manufacturing. So I don't want to go deeper on the explanation of this concept because I leave the floor to my colleagues to better explain you this concept and how it was born and how it can be applied with different immersive technologies. So I leave the floor to Marc Pallot, that is an associate researcher at ENSAM. So first of all, thank you for your participation. And I hope it will make us understand how this trend of the do it together approach emerged. So I asked Marc to introduce himself briefly and how he is involved in our project. And also I asked him if he can explain us how this kind of approach was born and in what context. Marc.
Thank you, Sylvia. I just hope I can get my presentation now.
Okay, have you the permissions? Okay. No. What should I do to...
Here it is. Oops. Moving too quickly.
I know very well.
Wow. Is there someone that is playing with the screen? Okay, so my name is Marc Pallot. I am, as you said, the research associate at the Presence and Innovation team at Marfisi Institute of Technology in Laval, and also at the Center for Concurrent Enterprise at the Nottingham University Business School. I'm doing research on user-driven innovation, new product development, user-centered design, and all the other concepts around like user experience and so on. I'm also an adjunct faculty member at the Jyväskylä University of Applied Sciences, where I'm teaching open innovation, user-driven innovation, and everything I was mentioning before, like user-centered design and so on. Okay, so my goal is to give you a kind of a quick overview of this history of the DIT approach. For sure, most of you have heard the term do-it-yourself. In fact, this term do-it-yourself was already used in the 60s, and it has been used in the community of hippies, you know, the peace and love, freedom, and so on. Because there the concept was about getting out of the consumerism society in saying that everyone can produce his own food and produce whatever he needs, and then he can exchange with the other persons, so which is a way to get out of the consumerism society. So apparently it seems that this concept of do-it-yourself, this name DIY, was already used in the 60s. For sure, it has been also mentioned in a famous book by a very well-known writer, that is Alvin Toffler in 80, because he has also created this concept of prosumers. And prosumers represent people that do both produce and consume. which is more or less reflecting this idea of DIY in the 60s. But it was as a kind of anticipation on how the society could be transformed in a way that the consumers are not only buying and using things, but that they can contribute to design and produce and consume things that they are able to produce. For sure, it has not been so famous in the 80s, simply because the means to produce something else than just food was almost impossible. But in the 90s, has emerged what we know as being the additive manufacturing, if you prefer 3D printing. And this 3D printing was a way to start manufacturing something that people wish to have. And it has contributed to the DIY movement because it was a way to provide the necessary means that people could produce different parts of their equipments in a view to make them more sustainable, which has an impact on the life cycle of the equipment that they buy, instead of just dropping them away, that they could continue to use those things. So the DIY movement has turned into a kind of a community of makers that is pretty well known in the Fab Labs environments. So the Fab Labs are more or less a kind of workshops, physical spaces that are existing all around the world in different cities. So people, individuals, they can join the Fab Labs, and then they can redesign or use existing design and produce the parts they need to sustain whatever equipment that they would like to sustain for having a longer life cycle. At the same time of the DIY movement, there was something else that has appeared later on, which is about how to get any kind of individual citizens involved in a way of personalizing any kind of goods. So, and it has turned into this concept of social manufacturing, which is a way in somehow to democratize manufacturing. It has been demonstrated in the context of the fashion industry by Hirscher and colleagues in 2018, so quite recently. And in fact, social manufacturing is a way to bring people into the production process in a way leading to new value creation. And it has been more or less the starting story of the do it together. Why do it together? Because for doing this, they need to get other disciplines involved, not only the makers, but designers, architects, and whatsoever kind of disciplines. And they have to collaborate and do work together in order to be able to produce new goods that people can personalize. And this was also demonstrated by, again, Hirscher and colleagues, and also by Young and colleagues in 2016. So let's say that the do it together approach was more or less already existing before we started to work on this concept. Sorry, the slide is again moving too quickly. Okay, so I was just explaining that there are scholars, a lot of scholars have been working on this concept and notably on the social manufacturing concept. For example, Young and colleagues, they see it as a way of doing the crowdsourcing for being able to produce whatever people want to produce. And in fact, they were also seeing the transition from mass production to mass individualization. Personally, I'm not totally convinced about the mass individualizations, but for sure, there are individuals that would like to get something that is more personalized than just getting a few options about the color or something else of the good that they want to use. I was also explaining just before that Hirscher and colleagues, they see social manufacturing in a way for sure to produce physical goods, but also to contribute to the other activities like ideation and design, and not only production. So the social manufacturing concept is in fact more or less covering the whole cycle of product life. Let's say it like this way. So in conclusion, the do it together is in fact an approach where people can contribute for creating value and then for designing, so which means that implementing the necessary features to get the value elements, and also for producing in a way that they don't need to wait companies to produce what they want, but also that they could contribute in using additive manufacturing, 3D printers, and whatsoever kind of robotized manufacturing units to be able to produce their individualized good. So that's why there I'm also mentioning a variety of customizable products. And the final goal is for sure, as you can see there through the different objectives and value elements, to have higher rate of customer satisfaction, adoption, and retention at the same time. Before that, you have seen that there was a kind of a synoptic to introduce the do-it-together approach, where you see the link with the Open Innovation and Open Innovation 2.0, but also the link with the Web 2.0 that was also at the origin of the do-it-together movement. And then it has turned into this renewed approach that we use in the INEDIT project, which is more or less involving a complete innovation ecosystem. So on the one hand, there is the knowledge ecosystem, and on the other hand, there is the business ecosystem. And there you have seen different elements, but more or less the ideation, open design, and manufacturing. And on the other hand, the value elements, the potential innovation intermediaries, and the business model that you will hear in a few minutes about. So in terms of objectives and values, there you can see that regarding the values, there was also this inspiration from the circular economy, so which means that we could design something globally, but then it is produced locally. So no need to have the products traveling around the world, but it could be produced just locally. Okay, so in which context we have been renewing the DIT movement? In fact, it was elaborated during this INEDIT EU Innovation Project proposal, in which are different elements like customers, consumers, users. They are expected to contribute to the design and manufacturing. So that's why open design and manufacturing of goods or whatever they wish to get. In the context of the INEDIT project, the experimentation is more on the furniture sector, or more globally the furnishing sectors. And they can do that for the experimentation through the what we call immersive experience design, so which is a kind of immersive and collaborative environment based on the use of extended reality technology like virtual reality, augmented reality, and mixed reality. technologies. On the one hand, for the open design, because there's a challenge is to turn any kind of individuals into, which is a kind of a novice designer, into a kind of experienced designer, thanks to the support of the immersive experience design, in which the individuals could create the usage scenario. And also through the automated manufacturing, as I did explain before, with the additive manufacturing, 3D printers, and any kind of robotized unit for being able to produce furniture or whatever components. Okay. So in which way this DIT approach would be different from the open innovation paradigm and from the living labs principle, assuming that you have already heard about open innovation and living labs. So for sure, there are both of them participatory approaches. But in a way, the DIT approach has inherited from the all the things that were done previously, like the user-centered design methods, and the living lab principle, which consists to turn the users from subjects into value co-creators, which means that they have the capacity to customize or personalize what they wish to have in terms of furniture or what any kind of good that they would like to have. And at the same time, the DIT approach combines the user-driven innovation, because in that case, the innovation is not driven by a particular organization or particular company, but is driven by users or whatever consumers, customers. And this is linked in a way in combining user-driven innovation and experience design, or the immersive experience design in a way, on a kind of a platform where individuals could come together and co-design what they would like to have as kind of a personalized product, whatever furniture and so on. So presently we have been working on the elaboration of the immersive experience design that combine both the user-driven innovation and experience design for non-designers or novice designers collaboration with other professional stakeholders like the makers, the producers, architects, professional designers for the furniture, for example. And there will be evaluation through a series of experiments. And the first experiment has been carried out as a kind of initial stage for looking at the impact of visual representation and how it is easing the way of co-designing for novice designers, for individuals. And this has been published in a conference paper that for the ICE 2021, and also the identification of the DIT potential benefits and eventual drawbacks. And this has been not yet published, but should be published soon in a special issue article in end of this year or next year. Thank you so much for your patience. And that's all for me.
Thank you. Thank you, Marc. So for everybody, if you have questions, we will ask them to the speakers in the end of the session. But if you want, you can start writing them in the chat. So at the end, I will ask the speakers to answer to them. So I think that Frederique has connection problems. yeah, we can clap, of course. So Frederique has connection problems, so I will see if in the end she can discuss with us about the do it together concept as a process. But now we will go on discussing about the technologies that can support this kind of approach. So I leave the floor to Sylvain Fleury, that is a researcher at ENSAM, and what I would like is to understand why virtual reality makes sense for the do it together approach, and also for the design phase of this kind of approach. In the project, we have developed different technologies supporting this kind of approach. So now we will see how virtual reality technologies can support it, and later on how artificial intelligence ones can support it. So Sylvain, please,
Yes.
the floor is yours.
Yes, I will stand up. I don't have any slide. So, hello everyone. I will start by introduce myself. I am researcher at the École nationale supérieure d'arts et métiers, we can say ENSAM. I am specialized in human factor related to virtual and augmented reality, particularly in the use of virtual reality for design. In the Untitled project, sorry. In the Untitled project, Arts et Métiers developed a virtual reality tool used to design the furniture, and my personal objective is to conduct experiments on these tools to make them understandable and easy to use by the future users. So there were two questions in what you said, Silvia. The first was why virtual reality technologies are relevant for design. So there are several reasons that I can explain. First, to understand the added value of VR for design, we have to compare it to other types of tools and to understand what are the consequences of each tool usage on the cognitive processing of the users. For example, when you sketch product idea with a pen and paper, you may draw 3D things on a 2D surface, right? So between your imagination and your sketch on paper, you have to carry out mentally some transformations of the shape to make a 2D projection on the surface by sketching it. When you are in VR, you don't sketch on a surface, but directly in 3D around you, thus you don't have to do this mental transformation. We can make another comparison when we use a mouse and keyboard to represent 3D shapes on screen. Interface of the software can be more or less relevant in terms of user friendliness, but in all cases, there can be no direct correspondence between the gesture and the result obtained. You know, your hand is not on the 3D object, but on the mouse. You move the mouse to transform something on the 3D object, but the link between the gesture and the result is not direct, and this reduces the spontaneity of the use. Tablet, touchscreen tablets could improve a little this problem, because when you want to interact with something, you touch it directly with your hand, and VR, virtual reality, can be even better. In VR, some software allows the user to sketch directly around them just by moving their hand with a pad into. In this situation, the results correspond directly to your gesture. This means that the users can use the VR tool more spontaneously to represent their idea, because they use natural gestures that is beneficial to the process. Another reason of the relevancy of VR for design is related to what we call the spatial inspections. When you design something, you alternate between two activities, modifying the shape of the object and inspecting the shape of the object. Inspection is when you watch the work the work in progress to identify something that you can improve or to think about how to finalize the shape to make it relevant for its function. Some researches revealed that if you work physically in VR around your design in progress, this is more effective than if you make your design turning on a screen. You will see more problems and easily imagine solution in VR that on screen, because in VR you can be in scale 1 with more feeling of presence, and it is easier to visualize the use. The last reason why VR is relevant for design is that in VR you can immerse the designer in a specific virtual environment that will have a beneficial effect on his cognitive functioning. I will give you a precise example about that. Researchers in psychology have long known that cognitive performance tend to be better when people are in natural environment. This phenomenon is named attention restoration. It's based on the fact that when someone looks at plants, it tends to relax, to rest the mind, and that restores the attentional resources. Based on this phenomenon, I published a research revealing that when people are sketching their ideas in VR, they are more creative if they are in natural environment. That was in a natural forest, virtual forest. They are more creative in the virtual forest than if they are in a virtual office that is not inspiring at all. So you can choose an environment that makes the cognitive functioning well, and that is an added value of VR for design. To answer more quickly to the second point you mentioned, Silvia, why VR technologies are specifically efficient for the IT approach. As Marc Pallot mentioned it, in Do It Together approach, customers are involved in the design process. This is a real challenge to involve non-designer in design process. To do it, we have to provide them with relevant tools which they will be able to use. So usability of the design tool is an extremely important point to consider. To be fair, I cannot say for sure that VR design tool can be really enough simple to make all the design steps accessible for non-professional people, but this is one of our main challenge in the project. We are currently conducting research about that. We know that training is very important to use traditional way of design, pen and paper and classical computer-aided design. If you are not trained to work with that, you cannot draw or model anything correct. But we think that it's possible to use VR tools to sketch idea and to model furniture with interaction methods that are simple enough for non-professionals to use. The other characteristic of the Do It Together approach is a together concept. To have a Do It Together project which work, we must facilitate collaboration and mutual understanding between the stakeholders. We can have customers, designers, makers, manufacturers working on the same furniture, and they have to be able to communicate and to work together. Without VR, they would be required to use email, discussion forums, video conferences to communicate. With VR, we can imagine that these people will be regrouped in a same virtual environment to work together on the same 3D model. They can have some tools to facilitate collaboration, work on the model, sketch, take note, discuss, being together near the 3D model. They are not forced to work synchronously. One people work on the 3D model and later another people is coming into the virtual environment to correct something or to add a note suggesting a modification, for instance. And finally, if somebody need a personalized furniture, it can be because there is a very specific context, as for example, a particular corner in a wall and so on. But there is maybe something uncommon in the place, and you have to consider it, this specificity, to design well the furniture. To do that, we developed in the project an application usable with smartphone or tablet based on LiDAR. This application allows the user to easily scan their environment in order to immerse themselves in it in virtual reality, to be able to sketch the volume of their future furniture directly in the right context. With this, they can take into account very easily the specificity of their place in their design project. To me, these are the main reasons why VR is relevant for do-it-together approach. That's it for me, Sylvia.
Thank you, Sylvain. I realize, listen to your explanation, that since we missed the presentation from Frederique, we also maybe you didn't completely understand what we have at the end of the Inedit project. So basically we will have a platform that is made by an online website, some technologies and some hardware. So from the website, the user can access to this kind of platform and can have access to the technologies that Sylvain mentioned, and in this way he can design the desired furniture and following a sequence of processes, and also launch the manufacturing of the furniture that he wants to produce and to have. So going on, still dealing with the technologies that can support the IT approach. Now I leave the floor to Carlos González from Aalen Technological Center, that he will explain us to this kind of approach. So I ask Carlos to briefly introduce himself, and I have mainly two questions for him. So how I would like to better understand how artificial intelligence can be useful in a project like our, with the design phase that is at the center, and in case if you can give us some examples, and also if you can explain what is generative design and if it can be beneficial for the IT platform approach and platform. So Carlos, please. Do you have a presentation? Yeah, it is. You can start. We do not hear you. So I don't hear you. I don't know if the other do.
No, I can't hear either.
No.
Okay, Carlos, I suggest you to log off and log on again because it seems that your internet connection is very bad.
Okay, in the meanwhile, if you have any question for Sylvain or for Marc, we can start discussing.
Or maybe we can start the last part about business model and Carlos finish after.
Okay, since the time is also running and we need to finish in 15 minutes. Okay. I'm sorry
I just upload the presentation of Tobias and Andreas on the other screen, on the other side of the room.
Okay. Thank you. So I'm sorry for that because we are missing two presentations, and I'm really sorry.
Sorry, if you don't mind, sorry to interrupt. Use the other screen because it seems that we only have two options for the screen zoom. So maybe the audience won't see anything. So use the one behind you, screen number 2.
Okay. I will upload it. Just 1 minute. It is uploading. Okay, so.
Okay, so this was supposed to be the last part. So how we can reach the market. So what's the business model, the proper business model for this kind of approach? So we have today here Andreas Kulschbeck, sorry for the pronunciation, from Aachen Hochschule, and I asked him to have a brief presentation of himself, and what we would like to, I would like to understand from the beginning is what makes the DIT business model so special. So what's the business model behind the DIT, and what it makes it so special, and what do you want to achieve with it in the end?
Perfect. Thank you, Silvia. My name is Andreas Kulschbach. I'm a research assistant on the RWTH Aachen University, and yeah, in case you saw this slide before from Marc, it's a little bit changed in detail. So let's try to guide you through. Let's stay at the first page. Thanks. So the business model is building up on all the technologies which we are developing in the project. So it's a pity that the other slides or other presentations haven't worked well, but I try to keep it simple to work out what problems or what special issues occurring in the business model development. So first of all, this slide, as I said, was shown by Marc Pallot in the beginning, and this is the the version from the business side, business model side. So on the left side, you can see what is the characteristics of our project and what is the most important things that we want to achieve. And in case from or for the business model, we have to take into account especially the business to business, but even the business to customer side. So this is something very special that we want to combine all these views. We want to create a platform which can be used by consumers, but also can be used by producers. So there are two different sides. The one side is the creation phase, the other side is the production phase. So on this side, we have a special issue what we have to take into account. The other thing is the sustainable driven and circular economy. I think in today's world, we need to think about this, and the business model concepts should be take this into account in all processes which is carried out on the platform. The next thing are the open innovation and co-creation processes, and there we are discussing what is meant with open and what is meant with innovation. So we have to protect intellectual property from all sides throughout our platform, and we have to take this into account within our business model. Overall, this is a project funded by the European Union. We have to fulfill some engagement from industrial SMEs or customers or other stakeholders and point out that they can be creative and bring in their competencies from different sides. So we have to clarify within the platform and the business model which one can get which value from which competency and which is bringing the most value for which process step. On the right side, you can see which objectives occurring through these characteristics. For instance, the most charitable thing is the transparency and the sustainability within a production or creation network. So the thing with the production and products, when you have different stakeholders within these processes, you all have to take into account this things. And another thing is the transition. I will jump to the last point on the right side. We need to transform ideas into objective and production data. So we need to think about technology, which is in fact the key aspect of our platform, and this is something what we are using as our USP, for example. So these are the challenges, and which is the differentiation to other normal business models, that there is a bunch of stakeholders which we have to manage. And on the next slide, you can see which different, and this is an easy one made for this discussion today. When you have different stakeholders, we wanted to point out which interactions there on the platform could be, and which fees or which selling and subscriptions you need. So there is a bunch of possibilities we have to take into account, and this is a great challenge, because when you are on the creation side, you don't have an object which you can measure or which you can divide into parts and saying, okay, this is your part and this is my part. So when you're talking about ideas and open innovation, the feeing and the billing of your service which you're giving to other stakeholders is quite hard. And this is something the platform in the core should be able to manage. And there you have to offer different technologies, functions, and combine this with some payment methods, for example. And then you have to decide which one or which service you can offer throughout the platform, which is free to use. And this brings me to the last point. We as a platform have to be working sustainable, so the operation of the platform should be sustainable. And we also need to earn money. And this brings me to this slide. And this is something we are working out within our work package is, which scenarios for the future for the operating of the platform are useful. So we are taking into account that there are 3 scenarios. First of all, there is some acquisition. So there is an existing platform or some challenger who's interested in the technologies we are developing, and he's buying all these and takes over the platform or integrate this into his platform. The second one would be the possibility to build a startup. Maybe some consortium partner will form a startup mentality to push this. And the third scenario would be an NPO where different stakeholders, it could be manufacturers, could be designers, are closing a circle where they are building up an association and saving these functions or the funding for the operating of the platform. So you see there are different scenarios, and for when we combine all these problems, you see that this is the main challenge in creating a business model, which on the one side is supporting open innovation processes with the creation and production side. And on the other hand, implementing different methodologies or functions to guarantee a sustainable running of the platform. And maybe you have to adapt your business model based on the scenario you're using, because a startup want to earn money with a platform. An NPO don't want to earn money with the platform itself, but want to earn money with the processes or services which they are offering about the platform. So these scenarios has to be defined in the future, and for this we have to adopt the business models and the function of the platform again. But this would be an iterative process for the future. Yeah, this is something we wanted to show you, and when you have questions, or I would hand over to Silvia again.
Thank you, Andreas. Fortunately, we have still some time to make everything working in the end of the project. But on next autumn, I guess on October or November, no later than November, we will have the first version of the platform running. So if you are interested on keep posted on it, or also start testing it, you can leave your contact in the other screen behind you. I have put a quad core that you can use to subscribe to our newsletter, and we will have your contact if you want to get news on the project and on the platform. So Carlos is back. We do not have too much time, but Carlos, if you want to briefly describe us how the artificial intelligence can be useful for our project, and give us some example, the floor is yours.
Okay, thank you, Sylvia. I hope
now we hear you.
Great. Sorry, I had some issues there with the microphone. I think you can see my screen now.
Yes.
Yeah.
Yeah, hello. All right. So, well, I won't go back again on what's the Untitled project. I think you all know it by now. Basically, our goal here is to create a platform where users, designers, and manufacturers can interact with each other, creating a do-it-together approach or an open manufacturing, a social manufacturing platform to offer the customers fully customized and personalized products that are also sustainable and locally produced. At the end, what we have here, it's a social manufacturing scenario where we try to engage all these users to collaborate with the manufacturers and the designers. But this, of course, implies some challenges. And for me, one of these main challenges is how to engage users that have different, very different skills to technical or design, and how to engage all of them in a way that they feel part of this design process and they can collaborate whenever they can. For example, if you ask me to draw a chair, I will probably draw something like the thing you can see in the screen there, which is not very useful for a designer. And on that direction, we were trying to explore the use of generative algorithms to empower these users. Hello? Okay. So they can be able to design their own things without the actual technical knowledge. Basically, what do these algorithms do? It's to create new items based on some criteria, like, for example, some shape or some function. And the user can evaluate them and check whether it's something they like or not. Basically, these generative models, it's a family of artificial intelligence algorithms. There are plenty of examples in the internet. And what they do, it's if you show one of these algorithms a lot of examples of one thing, for example, in the right corner, pictures of cats, it could learn to create new pictures of cats. And in some recent years, there have been some approaches to take this technology and move it to a 3D space. And this is what we're trying to do for Untitled, basically. We are showing this type of algorithms a bunch of different furniture items, so they can learn, for in this example, what a chair is, and are able to create new items from scratch. In this example, for example, we have a two-step algorithms where we create like a bunch of shapes for chairs, and we further refine them with different aesthetic options. So a user without technical knowledge can select one of these chairs on top, apply some filters, and get a 3D design without the need of drawing it or design it in a CAD program. And further, some of designs can actually be directly manufactured. We're making some tests with pipelines that completely automate the design, like these two examples on the left. And we create the actual physical objects, in this case at 1/10 scale, with a 3D printer. And at the end of the project, we would like to recreate these same pipelines but with real size objects and with better designs. So basically, the main takeaways here it's that these generative algorithms are very powerful tools for designs, and especially designs based on aesthetics. And we think it's a great option to boost the creativity of users and offer them a way to interact with designers and with manufacturers without the need of technical knowledge. Well, there are being implemented right now in many contexts, in many design softwares, but there are no frameworks available at the moment. And the last point would be that the combination of these algorithms with technologies like 3D printer can lead to mass customization of objects, where some user can completely design their product without and manufacture it without the need of any technical knowledge. And that was but I think that's it.
Thank you, Carlos. Thank you very much. And thank you also to the other colleagues that participated in this session. Since the time is almost over, and I do not see any question in the chat, I invite you to contact directly the speakers if you are interested in go deeper in some concepts. So you have the names, and they are here, so you can contact directly them in the chat. And also I invite you, of course, to leave your contact for the inedit communications.
Well, thank you very much for the discussion and your presentations. Now it's time for the next paper. So I'll take the control over the screen. So we are waiting for the authors. So the title of the paper is extending OpenSG for real-time synchronization of immersive environments in distributed collaboration. Sorry, please can you avoid touching the screen? Please do not click on the screen. Thanks. Okay, so let's wait like 2 minutes, and then if the authors are not coming, we can invert the paper presentations, because I'm pretty sure Isa is here for the next one.
Yes, I am.
Great, thanks. So let's wait a few minutes and we'll see. Okay, so I think we should invert the presentations. Isa, would you like to present your paper right now?
Yeah, sure. No problem.
Thank you very much.
So
Appreciate
I'll
it.
just, maybe I just want to show.
Yes, just take the control over the screen and just put the link of your presentation and then it should be fine.
Hi, everyone.
Oh, you can share your screen directly. Oh, is it your video?
I'll show, yeah, I'm gonna upload my slides. There you go. It's just so that you can see me. And I'm gonna show you something else too, just to wake you up. Look at this.
That's nice. I mean, I would like to see the
Sorry,
same
I love
in
doing
the real
that.
environment.
No, I can't do it for real. Oh, wait a second. Why are my slides not working? Maybe I have to stop sharing. Yes, that looks better.
Perfect.
Okay, so.
Thank you, Isa. Let's go.
Let's go. So, sorry, I'm just gonna put it back one. So my name is Isa Marfisi. I am a computer science researcher at Le Mans University in France. And today I'm going to present the method that we used for designing a mixed reality extension of an educational board game on fractions. So as you may know or maybe remember, fractions are one of the hardest concepts to learn for children. And this is a problem because it can lead to math anxiety. And even worse, if this continues, it can develop into anxiety about science in general. And this is obviously not good. So the challenge is to make fractions more easy and fun to learn. In this project that's called Smart Fractions, we have a partner that's called the Plaisir Math Association. And it's an association of math teachers, French math teachers, that develop games to teach math in general. And one of the games they developed is called the Potion Workshop. So as you can see on the picture, this game is used in primary school, the end of primary school. It's used to introduce the notion of the fractions. And it can be played with it can be played in a team of two against another team of two. And the objective is to make a potion by selecting the right number of the right fraction of the ingredients. So there's 4 types of ingredients. There's frogs, rays, spiders, and snakes. So the objective is to take the right pieces, and you can see on the board that the pieces, wait, I'm going to get my laser out. I forgot about that. Yes, as you can see on the board, you have the pieces are already pre-cut into units, halves, thirds, and etc. So this game works really well, and it's actually used in more than 5,000 schools in France. So our objective was to design a digital version of this game and use mixed reality to provide feedback, automatic feedback, so that the students could be completely autonomous. But as you will see, this quickly changed as we used our research method, which is called the, sorry, I'm just going to move back a little bit there. So we used, as researchers in technology-enhanced learning, there's a research method that we like to use, which is called the design-based research method. Basically, it means that you implicate the end users from the beginning, from the start of the project. And instead of having just one session where you design the game, you actually have several. So here we're up to 4 design cycles, but you could actually have more. So the idea is that in the beginning, there was 1 math didactician, 1 serious game expert, and 1 developer. But very quickly, we involved other people, and especially teachers, so that we could design games, design this application that was meaningful and, useful and usable in class. So the objective was to to implicate these end users, and not only the teachers, but also their students. So you see that in all, once the project will be finished, we will have implicated 7 teachers and their classes in this co-design methodology. If you look at the design, this method on a timeline, you can see that each design session starts with each design cycle starts with a design session. This is very important. During this design session, we design, how can I say, we identify the pedagogical knowledge that we want to include into the game, the interactions, and we make mock-up models. This session can last up to 5 or 6 hours, so it's very intense. And after this, what we do is that we develop a prototype. And there's not just one prototype, as you can see. Now we're already up to the 3rd prototype. Here you can see little screenshots underneath. So obviously they get better and better, hopefully. And what's interesting is that this prototype is then used during the next design session to really understand what we're working on and how it can be improved. And so this method, I've been using this method for all of my projects since I've been a researcher, so quite a bit of time now, almost 10 years. And I have to admit that, well, this method is always useful, but I really felt that it was especially useful for this project because we were dealing with innovative human-computer interactions. For our game, for example, we were using mixed reality interactions. And I don't know if you, well, you obviously, you two working on innovative human-computer actions, you see how difficult it is with a mock-up model, for example, to explain the interaction itself, to explain what is digital, what's real, how the interaction actually works. So these prototypes were really valuable for our project. And even if it takes time to develop them, obviously, I think it was a really good idea because it really allowed us to make something, well, to really co-design together, to implicate the teacher, who had no idea what mixed reality was in the beginning of the project. And what we figured out was a new way of learning mixed reality, and I'm sure we would have never figured it out if we didn't have this prototype. So indeed, what happened was that when the teacher was testing these prototypes, she told us that one of the main difficulties in learning fractions is the fact that this concept is taught with several representations, several different types of representations that are not linked together. So if you look at the representation that we mostly use, especially in the beginning when you learn fractions, you see that the fractions are shown as parts of an object. This is what we use, for example, in the potion workshop, but it's also what we use when you do an exercise on dividing a pizza or dividing a cake, for example. So this is a very simple representation, but it also induces didactic obstacles, such as the fact that a fraction can't be bigger than a unit, and also the fact that you can't really mix different fractions. For example, you can't add a piece of pizza to a piece of cake. I mean, it doesn't make any sense. So this representation is simple, but you use it in the beginning, but the good representation, well, the most complex representation that is more accurate, let's say, and that is introduced later on, is fractions as a cursor on a number line. So it looks more like this. Obviously, this representation is much more complex for children, but it introduces the notion of fractions as numbers on which you can do operations such as additions, divisions, etc. So this is actually the representation that we want to, how can I say, the goal representation that we want to achieve. But in the beginning, fractions are shown more like this. So the difficult part is that children actually like fractions when they're represented like this, and it's very difficult for them to transition towards this representation, which is much more complex. And even though children were really good at this representation and they had acquired lots of knowledge on fractions, when they arrive with this representation, they're completely lost. And when we were testing the applications and the prototypes that we had during our design sessions, well, we figured that mixed reality is the obvious solution. Well, it seems perfect for this kind of problem, because with mixed reality, you can show simultaneously the two representations, these two representations at the same time, simultaneously and dynamically. So instead of our first objective, which was to create a digital version of the Potion Workshop, we decided to create a new game, which is an extension of the Potion Workshop, and which has the objective of bringing this new type of representations, which will be used after in class. The design method also allowed us to work on other concepts of the game. For example, the game pieces, we decided to reuse the same game pieces that the children used in the Potion Workshop. This seemed obvious because our objective was to build on knowledge that they already had with one type of representation to help them to do the transition to another representation. So it seemed like a good idea to reuse objects that they were used to using. We also worked on the story, the characters with the children so that we were sure that they actually liked it. And the game setup, so here you can see that there's a tablet with a stand. The game setup was also designed with the teachers to make sure that the application was actually usable in a normal class setting. So the result of this design method was that we created this completely new game, which is called the Magic Cauldron. It's a game that provides 4 mixed reality activities to help understand the equivalence between the 2 representations of fractions. So I'm not going to give you all the details, but basically you see here, there's 2 types. Either the objects are in the cauldron, and the objective is to place the cursor of the number line in the right place to match the numbers, to match the fraction that's already there. Or it's the opposite. That means that the cursor is already placed on the number line, and the objective is to place the right number of objects in the cauldron. So we were actually able to test the prototype, the 3rd prototype, with a full class at the end of June. So we haven't finished working on the pre-test and post-test, so I'm not going to be able to give you too much information about this experimentation. However, it was really positive because it gave us good feedback on the story and the characters. The students particularly appreciated the voices because we have the characters that speak with real voices. We had actors that did that. So we're definitely, we're not sure 100%, but it definitely looked like the children were enjoying themselves. So we can be quite positive about that. However, there are a few things that need to be reworked and improved for the next prototype. Whereas, for example, the link between the cauldron and the number line, the children don't look enough at the number line. It's for the time being, it's very thin and you can't really see it. So we're going to rework on the, on the visual of the number line. We're going to make it much bigger. We're going to make it like an object. And we're also going to integrate it more into the story so that it has more importance. We're going to try to make it as important as the cauldron so that it really attracts the attention of the users to this number line. We also have to improve the game pieces. For the time being, I don't know if you see, but we took the pieces of the Potion Workshop and we glued QR codes over them. So this obviously is not great. So we're going to try to rework the design and make so that the pieces themselves are recognized as what are they called? As markers, as mixed reality markers for the technology so that they can recognize the pieces automatically without the ugly QR code. So I think that's it. It was this, well, I only had a few, I don't know if I have more time to present, but here's the conclusion anyway. So I really encourage you to use this design-based research method, especially for finding meaningful ways of using innovative human-computer interactions such as mixed reality, virtual reality, augmented reality. This is especially important when you're working, when you want to find meaningful ways of using this technology with people who are not, tech savvy or who are not computer scientists, basically. And here, this was really the key to find new ideas of using mixed reality with the teachers. And I am quite sure that if we had not done this, if we had not taken the time to make prototypes and the design sessions, we would have never found this innovative way of using mixed reality. I mean, we would have still continued working on the project, but it would have been much less meaningful, I believe. This method also creates useful tools, because you're sure that since you're creating them with the teachers and with the players, with the end users, you're sure that the result will be useful and usable in the context that you're planning it for. However, I have to admit that this method takes a lot of time because of all the process, all the cycles, all the development of prototypes, and it also takes a lot of organization, because you need to implicate the teachers, the students, and in our case it's complicated because you have to find the right time, which is not during the vacations, not during COVID lockdown, etc. So I have to admit this year was a bit tricky, but I think it was worth it. Just to finish, I wanted to encourage you to go see the website of the project, which is here. If I have time, I can show it after. And there's also a video demo of the Magic Cauldron. I didn't really want to show it during my speech, because the objective was really to concentrate on the method, on the methodology, the research method. But we can look at it now if I have time, and I'll put the link in the chat if you want, so that you can go look at it later. And if you are in Laval, please feel free to stop by on this weekend. We have a booth at the Espace Mayenne. It's the A16 booth, and we will be presenting this prototype. That's it.
Thank you very much, Isa.
Do you want another flip?
Yeah, let's go. You can perform another flip.
Yoo-hoo!
That's nice. So feel free to ask any question in the chat if you want Isa to answer something regarding this presentation. So we have like 5 minutes before the next talk.
So I put the links for the website.
Chat. Yes.
And I'm putting the links for the YouTube presentation too. You can find it on the website too. There, if I have 5 minutes, no one has any questions? Wow.
I mean, we do have 5 minutes, so if you have something else to present, please feel free to share something.
I'll show you my video then. So you said the best way was to share my screen, right?
Yes, the safest way.
The safest way. Can you see what I see?
Yes, sure.
Okay, I don't think I'm going to put the sound. I'll do the dubbing if you want. So this is the experimentation that we did in class in June, and this is the application. So as you can see, it starts with a little character that welcomes you. It says, "Hi, welcome. You've discovered the Magic Cauldron." And in the beginning, the animals are going to create. They're going to create animals with the cauldron by doing potions. So they have to place the objects. As you can see, they're recognized. So as I told you, it's kind of ugly now. We have these QR codes stuck on the pieces, and then it recognizes them. And as you can see on the bottom, the same value, the value of the fractions appear on the bottom on the number line. And then there's the nasty guy. He's called Aalen. He comes in and he's very jealous of the kids because they can actually use the cauldron, whereas he's been trying for years. So he decides to freeze parts of the cauldron. And the whole game after will be to unfreeze the cauldron by like moving things, moving parts of it so that they correspond to the value of the fractions either in the cauldron or on the number line. And then Aalen comes back again. So there's different types of interactions. And what else can I show you? And then there's also this one where, for example, they can use the separator. It cuts the number line in separate parts. And what's interesting is that you can see in augmented reality the pieces, the game pieces, and it's the same size as the real pieces, so that kids can use the real objects to compare and make sure it's the right piece. Are you still following? No one's talking. This is very stressful.
Sure. I'm sure we understand.
Okay. Is the time up, or should
Now
I
you can
should I
go.
continue?
You can
Okay.
continue if you have anything else to present using the video. Let's go.
So here you see this is another type. So here the numbers, the fractions are on the number line, and the objective is to find the right pieces to get the same amount. And this is the end of the game. So at the end of the game, you've repaired the cauldron, and you make a little bat, and the little bat looks just like Arcane. And he actually starts liking it, and he decides to leave you alone and give up the cauldron to the children, and that can play after all. So all this story was designed with the children. Of course, in the beginning, it was just a scenario, and then they chose the characters, lots of different types of characters. They chose the ones that they liked the most. And we also even worked on the voices. So you didn't hear the voices here, but I'll let you go see the video if you want.
Okay, sorry to interrupt. There's a question from Samuel. So
sure, yes, please.
So in the chat.
Yeah.
So how do you mix your method with Scrum and user-centric design sprint?
With user-centered design?
Yes, I mean you can stay in the public chat. You have the question, but
oh.
Are we sure?
How do you mix your method with Scrum and user-centric design sprint? Okay, well, it's very similar. It is user-centered and it is Scrum. It's actually the research, design-based research is inspired by the user-centered design and by Scrum because of the different iterative cycles. It's adapted so that it works for research, because the objective is that you also have the researchers and the research objectives that also evolve at the same time as the product. So my project is really a perfect example of it working well. To be honest, I've done it in other projects and it didn't work so well, or it wasn't so meaningful, or it seemed too heavy. But in this project, I think because of the fact it was innovative human-computer interactions and mixed reality, it doesn't really, I mean, the first time I went to see the teachers, I said mixed reality. They were looking at me like, what is this? Then I showed them an example and they were like, okay, it's augmented reality. Well, then not quite. And so really the fact that we had, the fact that we were working with them with the prototypes was a real necessity, I think. Did that answer your question, Samuel? Yes. Okay, cool. Samuel says, can I use it for my girl who is in middle school? Yes, it's actually perfect for middle school. It's made for children from 7 to 11 years old. It depends where you come from, but in France, it's just at the end of primary school and the beginning of middle school. So absolutely, you can use it. For the time being, it's still a prototype, and so we still have to work on the pieces, the game pieces especially. And I would say normally sometime around January, or maybe for Christmas, we'll have a version that we'll put on the website. So keep posted on the website. You can follow me on Twitter otherwise. You'll get information like that. Any other questions?
Yes, what is your next project from Antoine?
What's my next project? Ooh, well, I have a cool project, which is, it's nothing with virtual reality. Well, actually it is. It's augmented reality. How can I say this? It's a tool so that teachers can create their own educational treasure hunts for their school outings. And we're working on an augmented reality tool so that the teachers can monitor the students and especially know where they are in real time. Because this is a big concern for the teachers, apparently. They get lost.
Nice, perfect. So thanks for the questions and thank you for your detailed answers. So we should move on to the next presentation. So as we inverted the previous paper, now
Anjela Mayer. Anjela Mayer. We are welcoming Anjela Mayer.
Yes, I'm here. Hello.
Yes, Angela, thanks. So you can take control over the screen here and share your presentation.
I don't see an load button yet.
So
okay, all right, it's here now.
Yes, nice, perfect.
I will try with the PDF.
You can also share your screen. I mean, depending on the kind of content you want to display. Please let us know if you experience any issue.
Converting just now.
Okay, great. So we're waiting, no worries.
It's stuck in converting. I don't know. Oh no, okay, it continues.
Yeah, so it looks good. I mean, it's the title of your presentation, so you should be okay.
You can begin.
All right.
Okay, let's go. Thank you very much. We're listening.
Oh, sorry.
Yeah, no worries. And please, people, do not touch and click on the screen during the presentation, because everybody can take the control over the screen.
All right. Hello, everyone, and bienvenue to today's presentation about our paper about extending OpenSG for real-time synchronization of immersive environments in distributed collaboration. So my name is Anjela Mayer, and oh no, back. My name is Anjela Mayer. I studied computer science at the Karlsruhe Institute of Technology, and after that I started as a research associate at the Institute for Information Management and Engineering. And there I now work in the research group for smart immersive environments. During my studies and work, I gathered experience in developing of MR software and applications. And now my research focuses on collaborative virtual environments, and in particular now on asynchronous collaboration methods. In the group of smart immersive environments, we have focus in research mainly on engineering applications, as you can see on the examples here. But let me introduce you to today's content. First of all, I will talk about the motivation and related work about the topic. And then I will present you our approach for a collaborative virtual environment framework. Later, we will see our results involving the performance testing and validation example. And in the end, I will also give you a brief summary and a short outlook on our development and research plans. There are some slides missing. Sorry for that. Anyway, let's start with the introduction.
So, no worries. I mean, if you need, you can share your screen with your actual presentation in case you have any issue with the integrated tool here.
Okay, I think I will continue like that, but if the error occurs again, I will switch.
Fine, perfect.
Good. So yeah, let's talk about collaborative virtual environments. The CVE is the short acronym for collaborative virtual environments, and there we talk about a virtual environment to perform collaborative work between possibly many participants. In our context, we will talk about synchronous distributed collaboration, just like here in the Laval virtual world. We cannot gather together in the same geographical location, but we can collaborate from our remote locations and at the same time. That means synchronous distributed. So let's talk about the state of the art and first of all about the state in the product development. As we experience in the past few years during many lockdowns, the interest in collaborative VR software just increased, as you can see here in this figure. So basically, the collaborative products can be divided into these sectors: business applications, which usually support asymmetric devices for meetings and getting together in the virtual space. Then we've got the engineering applications, which are focused on the interaction and also import-export of CAD and CAE data. Then we've got the education and training sector. There the applications are usually focused on a specific use case, and thus it is hard to generalize or utilize the implementation to other domains. And last but not least, we've got the social VR, which is focused mainly on entertainment and social events, but also casual getting-togethers. Let us also talk about the state in the research. There were several good reviews published on the topic of MR collaboration in the last years. I have picked two here. And on the figures, you can observe that especially from the year 2012, an increase in publications on this topic increased, especially in the area of remote collaboration. We can also observe an increasing interest. And on the picture, on the figure at the bottom, we can see that especially the entertainment gaming area, as well as the architecture construction area, gained an interest in MR collaboration. The popular research topics are currently on facial expressions, hand gestures and interactions, but also environment reconstruction and virtual twins. To summarize the state of the art, you can say that there are still many research opportunities, for example, in asymmetric collaboration, which involves different device types. That can be a collaboration between one participant with an augmented reality device and another participant with a virtual reality device. But another important point is that most of the published papers implements demonstrators to prove their concepts. But these demonstrators are very specific. Please don't click. The demonstrators are very specific, and it is hard to generalize them to other application domains. So this is why it is also important to research on generalized frameworks which enable an easy implementation of collaborative MR applications, which simplifies the creation of such collaborative virtual environments and shield the user from implementing avatars and implementing network technologies. Yeah, this is our focus at the moment. So considering this when searching for ready-to-go VR collaboration frameworks, which are preferably free of charge and also suited for cave systems, selection is significantly narrowed. Here are presented 3 open source collaborative virtual environments frameworks, which can also support cave systems. The first one is VRCAnet. It supports desktop and cave output devices. It is accessible for free on request from the author. The devices are represented, as you can see here in the picture. These are the heads or head positions and orientations of the user, but the user is not completely embodied in the virtual environment. Virtual communication is not integrated here, but the authors say that you can use Skype in parallel. And yeah, they pursue a centralized data distribution model. And they also plan to support simultaneous user interaction in future. The second one is CoVice. It supports many output devices, desktop, caves, power walls, and so on. It is an open source framework and available on GitHub. It has also integrated tools for verbal communication, so you don't need to use external tools. And it implements centralized and decentralized data distribution models. But because they use the master-slave system, where only the master user can manipulate the scene objects, they don't allow simultaneous user interactions. But the master role can be sent over to other users. In the VR UI framework, also HMD is supported as an output device. It is also open source, available over their homepage. And they also have user embodiment support. As you can see here, these are video streams of 2 users which are collaborating on scientific data. They also pursue the centralized data distribution model, but they as well do not support simultaneous user interaction. So this is basically the related work. And now I will present you our approach in providing a framework for collaborative virtual environment applications. So our solution is based on the PolyVR authoring system, which can be used to implement any kind of VR applications and is tested for over 10 years in our lectures. And it also shields the developer from low-level graphics implementations, for example. PolyVR uses the OpenSG scene graph library, and this is very efficient for distributed rendering. It suits well as an open source scene graph basis for game and VR engines, especially when you want to use the cave, because you usually need a rendering cluster. So OpenSG with a cluster system works like that. You see the figure on the top right. The tree is representing a scene graph. It's a hierarchical structure of the scene objects. So on each node of the cluster, a sub-part of the scene graph will be rendered, and OpenSG can synchronize between the nodes and put together the whole image for the representation. So our approach is to use the synchronization mechanism of OpenSG for the synchronization of not just the scene parts on distributed nodes, but for the synchronization of one shared scene between the remote machines. So it is just using the same paradigms, but for another applications and extend it. So here you can see the concept of a collaborative virtual environment involving 5 distributed users. On each machine, the replicated scene is rendered. And by synchronizing the local scenes, the users get the impression of a shared virtual environment there where they can cooperate together. That's the CVE here. It is of high importance to ensure that the local scene replications are representing the same scene states and that the scenes do not diverge. When a user changes an object in the local scene, the changes need to be distributed to the other scenes, the other participants. And for this, there are basically 2 data distribution models. One of which is the centralized model. It is a client-server topology, network topology. The server will distribute the changes to all the clients. And the other is the decentralized model where every participant can communicate with all others, symbolized here. So for our research, we want to pursue the peer-to-peer approach to prevent the upload of confidential data on a server. I can't go further into the implementation details, but yeah, I hope you can get the idea here. Our synchronization implementation basically involves 5 functions: filter, serialize, broadcast, deserialize, and apply. Basically, first we get the list of changes OpenSG natively tracks anyway. Then we pick the changes of the objects we want to have synchronized from this list, and we copy them into our own change list during the filter process. Then for the data distribution, we need to serialize the change entries into a data stream. And during this process, we augment the data with the necessary information for the later process of deserialization. Then the changes are broadcasted to all other registered systems. Here you can only see 2 scenes, scene 1 and 2. So the changes are sent over from scene 1 to scene 2. And in scene 2, the changes are received and deserialized back into change entries. So after that, during the apply function, the corresponding objects can be found because we added the additional information during the serialization. We can find the corresponding objects and apply the changes to these objects. So overall, we apply these scene changes of scene 1 to scene 2. This is basically the synchronization workflow. Okay, during the synchronization workflow, we encountered a conceptual problem. When the changes are sent from scene 1 to scene 2, they are received there, then applied to the scene graph of scene 2, and then the changes are registered again as new changes. The scene graph says, hey, we've got changes of the scene, so make the new change list. And then the created change list will be sent back to scene 1. So that results in scene 1 receiving back its own changes. They will be registered again, a new change list will be generated and sent back to scene 2. So overall, this results in infinite synchronization loops. To prevent these infinite loops, we adapted our filter method to filter out the currently received and applied changes from the newly generated local change list. So if scene 2 does not have any changes of the scene, but just receives changes of scene 1, they are applied, then they are filtered out from the list, and so it results in an empty change list, and we prevented the synchronization loop. So we've got another issue. Since we enable simultaneous and thus also concurrent user interaction on the same objects, we sometimes produce inconsistent scene states, as you can see here at the bottom. So in this example, when user A and user B want to simultaneously move the same object to different positions, user A to here, user B to there, they will generate change lists and send them across the collaboration network and also receive them. So user A will receive the changes of user B, which will override the position of the object, and vice versa on the other side. So at the bottom, we've got 2 different scene states, and the collaborative virtual environment is thus inconsistent. So to address this problem, we implemented a simple ownership concurrency control mechanism where each object is initially owned by one user. Like here, user A is the owner of the orange cube and user B does not own it. So when they again simultaneously decide to move this object, user A will be able to move it to the new location, but user B not. But we implemented the system this way that user B will automatically generate an ownership request and send it over to user A. In this example here, until the ownership request arrives, user A finished the action, so the system can grant the ownership. At the moment, the implementation is so that if the object is not occupied by the user, the ownership will be granted automatically, and the ownership grant will be sent back to user B. And only after the ownership grant arrives, user B will be able to interact with this object. And now I see here's an arrow in the figure, this cube should be on the top right corner. So the result is a consistent scene. Okay, let's take a quick look into the results. So we implemented our CV synchronization. We tested our synchronization functions for performance and also did a validation example. To test the performance, we generated many objects in a scene. The number of the objects and the complexity of the objects increased in each test. And we measured how long it takes to synchronize the changes of the created objects. So a bad value for the synchronization delay or for the delay overall would be 500 milliseconds, and a good value would be 200 milliseconds. At our state of the implementation, we only measure the application delay. So later, when the framework is finalized, we also need to add the network delay in different network infrastructures. Okay, here in this figure, you can see the delay behavior with an increasing number of objects for 5 different object complexities. Objects with lowest complexities had 100 vertices, while objects with highest complexities had 1 million vertices. And for high complexity objects, the recommended application delay was already exceeded when synchronizing one object. But for example, with low complexity, we can synchronize 750 objects creations during one synchronization loop without exceeding the 200 milliseconds. The next one shows the test results for complex scenes. So the number of children for each parent objects increased. And here we considered our implemented functions. Here you can see that the filter, the serialize, and the apply functions scales very bad with an increasing number of children for the objects. But we see much improvement capacity here. So we can optimize these functions in the future. While the deserialize function scales pretty good. Okay, I will only say for the validation that we in the end also were curious to integrate the collaboration module into an existing VR project. And this is visualized here in this picture. On the left is the view from a desktop PC user, and on the right there is a cave user, and on the right picture you can also see maybe the avatar of the remote user. So we come to the conclusion. To summarize this all, we have extended our framework based on the OpenSG library into a collaboration framework where collaborative applications can be simply implemented. But we have still much work to do. For example, we don't support verbal communication yet, and this is pretty essential. Our further future development steps are also full body or nearly full body avatars, massive user collaboration. At the moment, we only tested for 2 users, but we want to have 20 users. And also we need to improve the robustness of the systems. Our planned research topics are involving advanced consistency control methods, also user role management system where inside the team every user can have another role with different privileges and rights. And the last point are methods also for asynchronous collaboration, as for example the replay mechanism for user avatars. So that's it for my presentation. Thank you for the attention, and if there are questions, I will be gladly to try to answer them.
Thanks a lot, Angela, for the presentation. You can press F4 if you want to congrats. Nice, thanks. So if you have any question, we have time for 1 or 2 questions. So feel free to ask anything in the public chat or directly using your microphone.
No questions?
Just wait for just 1 second, because I'm pretty sure Oliver is currently asking a question in the chat.
All right.
I can see him typing on his keyboard.
Okay, so the question is, can we use HMDs with our project? Currently, we implemented an HMD support for SteamVR. We tested it on the HTC Vive Pro, but we didn't test it on many devices. And yeah, you can just plug in the HMD device, and once SteamVR is running and our application is running, it is just rendered in the HMD. And for the navigation, the fly stick navigation of the cave is just mapped to the HTC Vive controller, but we did not implement a separate controller interaction yet. But it is a work in progress.
So what is the next step? I mean, is it vocal communication or anything else regarding like massive user collaboration?
Yeah, it always depends on the projects we get. As everywhere in research. The next step is to finalize our peer-to-peer networking with a turn server. We implemented a turn server yet just for the connection of the users. But yeah, the data distribution just goes from user to user in a peer-to-peer manner. This is the work we currently do. The next will be to improve the avatars. Yeah, and what runs in parallel is also web browser support, so that our engine can render in a web browser as well.
Great. Thanks for your answer. So we should move on to the next presentation. So the last paper before the final panel will be entitled Leveraging Augmented Reality to Support Context-Aware Tasks in Alignment with Business Processes. And so I'm pretty sure our speaker is here. Yeah, Roy, I'm pretty sure it's your turn.
I've sent a message to him, but no answer.
Oh,
Yes.
is it out of keyboard maybe?
So put your mic on. Try to speak, please. Okay, can you go outside? We'll take a look at your sound parameters, please.
Okay, so we should wait a few minutes. Seems we have a problem to solve regarding the microphone.
No, sorry, Roy, they inverted the presentation with Angela and Isa switched. So it's your turn now.
Yeah, you were scheduled at 20 past, 5:20, and it is 5:21, so we're in line with the official schedule. But yeah, we inverted the previous presentations.
Roy, yes, you can change the configuration of the seats if you want. Maybe see that with Geoffrey.
Yep, I can change the room configuration if necessary. Would you like something else? So, guys, I do not have any information, so maybe you could tell us what is happening currently.
Roy, can you follow us outside? We'll take a look at your sound parameters. Can you follow us? Seems that Roy is having
moving,
some
so I
issues,
guess
so
you can...
we'll take a look at it. Okay?
No,
we'll
wait,
be back in a
I
moment.
can speak.
Great.
Okay.
Perfect. So
there's directional voice, so somehow when you talk behind me, then I don't know who's saying what. Okay, sorry. Okay, I'm up next. I thought Isa was next.
No, but as we told you, we inverted the previous presentations because we had an issue with the presenter, so we switched the order, but now it's time for your presentation, if you're okay.
Okay. Yeah, that's fine.
Thanks a lot. So you can take the control of the screen here and share your presentation. Just click on the big screen.
See, presenter two. Okay.
So we have a okay, so we can see a video currently. Okay, so we do have the title of your presentation, so you should be set up.
So, all right. Everything's fine with audio?
Perfect on our side, so you can begin your presentation as soon as you're ready.
Okay, thank you.
You're welcome.
Okay, right, thanks. Hi, I'm Roy Oberhauser from Aalen University in Germany. First of all, I'd like to thank Simon and the VREC organizing committee and the supporting staff also for this really cool opportunity here to present this paper, leveraging augmented reality to support context-aware tasks in alignment with business processes. If you have any questions, then please feel free to ask at the end of the talk. So increasing digitalization is affecting society and all domains and industries. In the manufacturing and production area, it is often referred to as the fourth industrial revolution or smart factory, cyber manufacturing, or cyber physical systems. Industry 4.0, first mentioned a decade ago, stands for using digital technologies in the manufacturing process and is characterized by a digital supply chain, digital products and services, and new business models such as high customization. Smart factories then add advanced technologies like AI to cyber physical systems. And the production machines or cyber physical systems are often programmed for certain repeatable tasks and then configured as needed. And current machine interfaces for humans often remain to provide status or allow interactions, but they're specific for that machine. They don't consider or know the global context, since the machine manufacturer is focused on the intent and the specific job that that machine has. So despite the strides in automation, as an example, current machinery in a fab, a chip factory, runs around 90% of the time with about 10% downtime for scheduled or urgent maintenance. And when a machine breaks, it's important then to fix it quickly. So furthermore, with digitalization, we also see an increased focus on IT and business process automation. And while process automation sounds great in theory, to actually model real processes and to take into account all the special exceptions and possible errors that reality might throw at you is actually quite challenging. As Industry 4.0 digitalization grows, both business and production processes and associated IT automation play a significant supporting role for increasingly complex scenarios. Yet the current process engines or business process modeling management systems have been tuned to enact a modeled process based on certain inputs that they receive. And for human-driven tasks, the interfaces are often web-based input forms that create an interface discontinuity for workers in an industrial setting. Such processes could include quality, conformance, regulatory, supply, or maintenance processes. These processes are often unaware of the other context related to the worker or the machine and lack the knowledge of or integration with the AR interfaces. So the processes can seem dumb. So industrial augmented reality is growing in importance as a way to support digitalization in conjunction with human tasks. And IAR provides a way to augment the real world with digital information for the worker, and thus influence the worker and provide certain limited digital context. The IAR devices are not readily tied into process-aware information systems, and thus they lack workflow support and process context, with the processes being unaware of IAR and IAR unaware of the processes. So IAR use cases often cited today in news articles include their use for overseas experts to help a local worker diagnose and repair a machine, but the tasks are not directly tied to any repeatable and modeled back-end process. So there are still information and context awareness gaps between IAR and the process context that could improve quality, efficiency, and effectiveness for combining worker tasks in processes. So we see here how IAR, they just show data really, but it's not really combined or brought into the process. So here we see an IDC forecast of the expected importance and usage of AR and VR technologies for industrial maintenance purposes. At 4 billion per year within 3 years, that's not insignificant. And we think that many opportunities to leverage these technologies will arise to better align digitalization and automation with human tasks. So besides gaming, as we saw on the last slide, more serious XR usage scenarios for industrial and manufacturing include the areas shown here. The focus for the evaluation scenario we will show later is on the maintenance and workflow areas, and especially bringing these two together, and it includes safety and quality assurance aspects as well. But any of these XR areas that is amenable to process support could be supported with our approach. There's been a lack of integration and awareness for these three areas of machines, business and industrial processes, and industrial AR. And integration and industrial augmented reality to support human tasks in production processes has remained limited, as the process engines have hitherto not directly supported nor integrated IAR. And also each of these three areas have their own specific context: the local machine context and state, the local process instance, and the overall organizational processes and their context and data, as well as the worker and the IAR context. Thus, the holistic integration of IAR and context awareness in business and industrial processes remains a challenge. So we contributed an approach we call Paradigma for holistically integrating context-aware AR into intelligent business processes. So our holistic Paradigma solution addresses context awareness with live machine production data and analysis using various data integration capabilities such as OPC UA and IAR integration with business processes, including the user's positional data and objects of interest at that location, gathering AR-based content input and user choices and interaction into the local process context, providing AR-based guidance and prioritizing and optimizing task assignments based on the overall context. So the Paradigma logical architecture consists of these extensible building blocks. The front end is a top layer, which supports our AR app. It contains the 3D models, videos, images, any AR content. Then we have a special BPMN app for modeling business processes with AR enhanced processes. And that includes any context attributes that are appropriate for the process. So looks like someone clicked maybe. Okay, so sorry about that. All right, so the IAR app then communicates with a Paradigma backend via REST calls, and the backend can integrate then with any commercial business process modeling system, process management system. So our solution considers many more facets. This paper is primarily focused on the IAR aspects. Okay, so to support quality during human task execution, we have a modular system of AR components with AR-specific content that can be utilized in the process, and is of course realized with Unity and handles various placement of the objects then in AR space. So, so next point then, here we're showing an industrial machine part replacement scenario, and due to the COVID restrictive industrial access this past winter, we simulated this within an academic setting that is analogous then to replacing a machine part. So here we see a BPMN model for our case study with extension points for AR marked with green. And for this scenario, an additional part, the PCI card, is added to a PC, analogous to adding or replacing a machine part then. We tested our system then with Magic Leap goggles, but since we don't believe all workers will have access to or want to wear those exotic goggles, we also tested it with a smart tablet. Okay, so now we dive into the process steps in more detail. Initially, the ask for assignment activity requests from the Paradigma backend to determine the optimal worker. We have an intelligent assignment component backend to enhance any business process management system that uses and weighs various factors using intelligent algorithms to determine the optimal worker to assign to a process. And based on that result, the worker is directly informed in AR of their assignment. Okay, then here there's the go to PC activity. The red spheres or anchors are used then to guide the user to the destination. We'll see that in an example demo video in a moment, but first I wanted to go through the process steps so that we know when we see the video what's really going on in the back end with the process. Settings on the top left can be accessed by the AR user, and the task list at the top right is available to them. And they see with the red button at the top right if they have a new assignment and can access that. And the active task in green is shown with a white checkbox at the top, so they know what their focus is right now in the process. And it's also an affordance to permit them ending a task at any time when it's done, even if there's something left over to do that hasn't been checked off yet. And they can at least say the task is basically done. Okay, so in AR then it displays a checklist of system hardware modification preparation, includes things like closing all apps, shutting down the system, unplugging things. And this is an analogy for addressing quality and safety or regulatory or conformance aspects when doing tasks in an industrial setting. Okay, so then we have in this AR3 extension point in the process, an AR video overlay is shown on how to open a PC case. And once the marker inside the PC is scanned, the video stops. And a 3D PCI card and mainboard overlay is shown. User can end the AR task then by selecting a check mark to get to the next active task at the top. Of course, it could be enhanced with gesture and voice recognition, but the principle remains the same. And with this guidance and the other aspects I've just mentioned, we've basically brought the back-end digital processes into the front end where the people are executing them and augmenting the real world and aligning these processes with the actual context in front of the worker. This shows them the benefit of our AR UI interaction for seamlessly connecting then the back-end process. And here we get into an error scenario. So the user here waits for the Paradigma context sensors to detect the PC and the PCI card, and it's equivalent to cyber machine sensors then. Okay, so on the left then, we ran into an error, it wasn't detected, so a timeout occurred, an error checklist is shown. They can go through the checklist then, and it's statically anchored, any checklist, to help them and be able to read and point and check things off. Okay, and once the card is detected, they've completed it. Basically, a completion checklist is shown. Once all items are checked, then the activity and the process are ended, and the Paradigma provides the next assignment. And basically, then the user didn't have to go to some web user interface that's outside of their current context. So what they're seeing in the process is basically directly right there with them while they're working with it. Okay, so now I'd like to switch to a video demonstration. So here we go. So here we see the process getting started, basically, as usual. Automatically assigning the task to the next best suited and qualified staff. Users notified at the top to move to the specified PC. Go to PC there. The user reaches the PC. The next activity is triggered, in this case, a checklist in the process. So in AR, the user sees a checklist that they need to perform. The field of view is much bigger in the AR device in contrast then to what we're showing in the recording. So with the controller, the user can check off the items and transmit the result to the business process management engine. The next task is supported then by video in AR and how to open the PC. So here we're showing in video, you kind of see it down there, but the user in the AR goggles can see it very well. The video on how to open it. There's also instructions then on how to put the PCI card in, but we're skipping that for now. So once the PCI card is detected, then you'd get assistance. But if it's not detected, as it was here, an error case, then this error checklist shows up for them on things they should look for in order to resolve the issue. And basically then in this context, we could look at that as equivalent then to being a machine, a replacement issue, or a supply needs to be put in, something needs to be done with the machine to resolve an issue there. So after checking for all possible errors, the system checks still if it fails or not. If it's detected, goes to the last task, and that's basically to close up the PC again, machine, and after connecting all the cables. And then we're done basically with the system modification task. Okay, so after finishing, the user gets his next assignment basically. Okay, and that's the end. So let's see, go back. Okay. So in conclusion, we contributed a context to our approach then for integrating IAR with business and industrial automation processes that are aligning worker contexts and situations with the organization's global and machine local industrial context. So it contextually integrates process-based IAR guidance and content. So we have AR content that we can bring in, even PDFs or images, whatever is needed to help the worker do their job, and can support them with whatever tasks, live task assignment optimization, improved task execution quality. Feasibility was shown. We've integrated it with 2 commercial business process management systems, and the machine case study demonstrated the primary IAR capabilities. So thank you very much for your attention. Any questions?
Thanks, Roy, for your presentation. So we have time for one question. You can also contact directly, I guess, Roy, if there is more. And otherwise, we have to switch to the last panel presentation. Okay, so I think our speakers are there. Okay, so if there is no question in the chat, I would like to thank Roy once again, and we will switch to the next presentation. Thank you very much.
Okay, thank you.
So the last presentation of the day is a panel, and we will welcome 3 persons to present and discuss around a topic entitled adaptive interaction in XR. So, Jean-Rémy, are you the main presenter? Would you like to share your screen?
Yes, we will be free, but I will try to manage everything.
Yes, perfect. Thank you. So, I'll let you share the content of your presentation on the main screen.
Okay, just wait a moment.
Yeah, no worries.
So, do you see my screen?
Yes.
Yes, we can see your screen and the interface of the software.
Okay. So I hope.
Yeah, perfect. So you're in presentation mode.
Yes. Just I need to see people. Okay. So thank you, Geoffrey, and good afternoon, everyone. So I'm Jean-Rémy Chardonnet. I'm associate professor at Arts et Métiers Institute of Technology, not in Laval, but in another place in France called Chalon-sur-Saône in Burgundy. And so on the other side of France, and I'm working on virtual reality since now 10 years, a bit more than 10 years, and especially on interaction in VR. And so today, with 2 of my colleagues, I would like to share with you some thoughts about a topic that is for us very important. This is on adaptive interaction, and so we'd like this panel to be very lively and interactive. So don't hesitate to interrupt us or to ask some questions or to make some comments. It's a very open discussion. So just before letting everyone discuss, my colleagues present what they have to present, very short introduction on the topic. So we know that with the increasing development of XR in many domains, the need for appropriate interaction methods adapted to the user and the context of use is more than ever essential. That means that we don't now need to have just kind of standardized interaction, but it's important also to consider that this interaction could be adapted to the users and the use case, the context of use. So as you see, and as you know already, there are many growing interest in all fields where virtual reality can be applied. So industry, in healthcare, in education, in art, and so on. And we know also that the XR market is increasing more and more. So this justifies this need to really change, let's say, the paradigm, interaction paradigm. So to meet this need, we consider that there are several prerequisites. And on the one hand, so we have to understand very well how the coupling mechanism between humans and immersive environments work due to the uniqueness of each person. This is important. And on the other hand, also we have the multiplicity of technical possibilities of immersion, and on the other hand, to properly prepare the data necessary for a successful interaction. So how we can gather data, how we can maybe create also data to improve interaction to its optimum for the users. So meanwhile,
you know, also you're aware that there is an increasing integration of artificial intelligence tools, which allows to consider new interaction paradigms in XR. So this is quite interesting. As we can consider, for example, intelligently adapt XR interaction to the user and the context of use. So that means that we can propose adapted interaction to the user. So this is represented by all the people that we see on the right side of the slide. So that each person, because each person is unique, each person can have its own interaction paradigm, let's say. And so with artificial intelligence too, we can imagine helping people interacting better, and so improving user experience in immersion. So what we will try to do in this panel, and again, I really hope that we can have some very open discussions on the topic, is to present some ideas or some thoughts on the subject, starting from the diffusion of the spread of virtual reality, extended reality technologies, especially in industry, because it's industry is the main, let's say, client of the main customer of XR, and also the understanding of human environment coupling, and then together with interaction paradigm that we try to develop at Arts-et-Métiers Institute of Technology, we will try to discuss some trends and topics to be explored. So just to present ourselves, so this is me, Jean-Rémy Chardonnet. So you can scan also the QR code with your smartphone if you want. So there is my address email in this QR code. We have also Florence Danglade, who is what you call in French professeur agrégé at Arts-et-Métiers Institute of Technology in the same laboratory. And so she will present some thoughts about the diffusion of XR technologies in industry. And on my in the real life, on the right side, my right side, I have Christophe Guillet who is with me. So actually, we share the same avatar in Laval Virtual World. So Christophe Guillet, who is also associate professor, he is in the same research team as us, but in a different academic institution. He is in the Burgundy University. And so he will talk about the understanding of human environment coupling. So, Florence, if you want to...
Yes, good afternoon. Thank you, Jean-Rémy. So good afternoon all. In this presentation, I'd like to present you a short outline of issues about XR in industry. That XR techniques are very powerful for training, assistance, supporting a lot of activities in the industry. For example, you know that they can facilitate the decision making, they can reduce the time of staff during design, manufacturing, or maintenance activities. They can reduce errors or improve learning, and that for over 20 years. Sorry, that's okay. And with a recent survey from users, give us the level of satisfactions and the importance of needs during the use of XR activities in the industry. This graph here represents the current satisfaction levels for XR activities in the industry and the importance of these requirements. So the current satisfaction level is 1 if the requirement is met for less than 20% of XR activities, and it is for if the replacement is met for more than 80% of XR activities. And the need of importance is 0 if the replacement is not important at all, and it is 4 if it is very important. So the topics that deserve our attention are those for which the importance is high and the satisfaction level is low. So we can identify some priority topics like easy and fast content creations or like else. Next step. Okay. And after this survey about needs, a trend analysis enables us to identify priority issues that are related to the work of my colleague, that related to interactions between human and XR applications. And these priority issues are, for example, the reductions of motion sickness, the improvement of human-machine interactions, the improvement of navigations, a best soft sense of immersion, and the improvement of haptics. There are all topics which the needs are very important, but they are not met today. Okay, thank you. So thank you for your attention. Okay. And next slide is for my colleague Christophe.
Yes. In the room, do you have already some comments or some thoughts about what was already presented? No? Okay, then maybe we can, Christophe, continue with the coupling between virtual environments and human. So,
thank you, Jean-Rémy. So the ultimate aim of the VR system is to technologically immerse the user into virtual worlds, inducing a sense of presence. But not all immersive VR systems provide the same level of presence. Measurements of virtual immersion, so-called sense of presence, have been studied by human science as well as engineering science for numbers of different use cases. Various parameters like latency, user's profile, and content of the virtual environment contribute to characterize virtual immersion. Many studies show too the added value of multisensoriality to enhance virtual immersions. But the sense of presence is classically assessed using questionnaires during which the subject would explicitly transform a body experience into verbal judgments. Thus, traditional protocols, also interesting to qualitatively evaluate the sense of presence, does not allow an objective measurement of a physiological state, resulting from several variables difficult to translate into verbal report. In order to address the priority issues related to interactions and thus optimize the subject's virtual reality experience, it is necessary to customize it. Standard XR applications do not allow this. So the scientific challenges are, on the one hand, to better understand the interaction mechanism between the subject and its virtual environment, and, on the other hand, to develop a quantitative method to evaluate the sense of presence and extract individual immersive profiles. Also, a sensory motor incoherence resides between the subject's action in XR and the system's response. The question of the perception-action coupling arises in a virtual environment as well as in a real situation. Its understanding is based on theoretical neuroscientific foundations, and more particularly on the notion of the mirror neuron that was a discovery of Italian researchers about monkeys in 90 years. Mirror neurons are the neural substrate for embodied communication. They are a particular class of visual motor neurons, originally discovered in area F5 on the monkey or human premotor cortex, that discharge both when the monkey or human does a particular action and when it observes another individual monkey or human. So let me explain you briefly, simply how mirror neuron works. When someone is observing or executing a movement, we speculate that the brain of the observer simulates the observed movement, meaning that this is a visual model that can be transformed into motor model. Also, motor laws are identifiable within a group of subjects. Recent works proved that there are nonetheless singularities that distinguish subjects from each other in terms of motor performance and the representations on which that performance depends. So we propose to extend this hypothesis to the VR context and to extract individual sense of presence modalities. To do this, we need to develop robust methods that are be able to extract singularities of movements. Combining topological data analysis and machine learning methods, we proved that we can obtain accurate results to classify data of human movements. So the next goal is to develop predictive and prescriptive models to propose XR adaptive interaction to the subject.
So as you see, as you can imagine, so the idea is to consider other means to develop interaction in XR, so not just based on classical studies or classical ways that have been done for many years now in VR, but to really imagine other completely different paradigm of interaction. So considering tools from mathematics, for example, or from machine learning, so from AI basically, that provide us very new challenges to personalize or to customize interaction as we proposed earlier. So based on what Christophe just said, I want also to add some more comments regarding interaction in itself. So as you know, and as Christophe already said, the main idea of virtual reality is to be able to interact, to immerse someone and interact with a virtual environment. However, usually users are limited in the physical space. So if you use, for example, the cave system, you are limited by the walls of the cave system, or even with a head-mounted display, you cannot walk indefinitely, because otherwise you cannot be trapped in the real world. But in the virtual space, you are allowed to move indefinitely. So that means you have an unlimited virtual space. And so, as you know, also there are many interaction techniques or navigation techniques that have been developed for many years. The first one, of course, being one of the first ones being the pad or joysticks. But you know that if we consider, for example, some criteria in terms of affordance, ergonomics, sense of presence, cyber sickness, and adaptability to the use case, for example, we see that none of the navigation techniques, here if you consider navigation, meet optimal settings as the natural walking, of course. So meanwhile, there are also different ways to mitigate issues related, for example, to cyber sickness with navigation. So, for example, developing new travel devices. So maybe you have seen in, I think in the exhibition, there are some providers, or at least in the past year, there have been at Laval virtual exhibitors showcasing travel devices, or like omnidirectional treadmills. There are lots of travel techniques that have been released in the literature, in the scientific literature, but we can also act on navigation parameters, because we know that, for example, if you have too high accelerations or too high speeds, you may induce cyber sickness quite easily. We can also act on the field of view. So there are some papers showing also that if you reduce the field of view while you are walking, you can reduce cyber sickness. But the problem is that if you reduce the field of view, then you have a very restricted vision of the virtual environment, which is not realistic. You can consider also taking drugs. There are some people saying that there are some drugs that allow you to reduce artificially cyber sickness effects, but this is not something that we try to push, of course, in VR. We can also put salient references like a virtual nose. You know, probably this paper, now well-known paper released in 2016, if I don't mistake, that provide also a way to reduce cyber sickness. Or you can also stimulate the different senses. So, for example, using a dynamic platform or different sensory stimulation means, and so on and so on. So there are many ways to consider improving interaction in VR, here especially navigation, which is one of the main issues. And this is even more important than if people feel cyber sickness, or if people feel discomfort or issues in virtual environment. Usually it leads to a rejection of the technologies. We often see people when they put a head-mounted display, for example, in their head, and they get immersed just maybe 10 seconds, even 10 seconds, they often just throw the head-mounted display away, because the virtual environment or the virtual scenario make them sick immediately. So we try at Aalen to develop different ways to interact in. So we studied also interaction as it is done usually in the literature for several decades. So we propose different methods of interaction, of navigation in VR. So you see, for example, considering gesture interaction, we consider using, for example, a smartphone to navigate. And we consider also something that we call the semi-automatic, which is inspired from the robotics field, and especially related to path planning. So the idea was to develop a method to compute a path, a trajectory that minimizes the trajectory and so avoid any unnecessary movements in the virtual environment. And we see that, and we saw from these different methods that we developed also, that there is no real good interaction method if we consider, again, the same criteria, so affordance, ergonomics, presence, cyber sickness, and the adaptability. Even if we have some hopes about the semi-automatic, but it is not where we want to go to. So the main problem, and this is also what Christophe said, is that what is developed currently and what has been developed until now is the same for everyone. That means that we never consider the user at the end, even though by definition VR is user-centered. But if we consider what is existing in literature or what is released on the market, nothing is done to a specific person, I mean, towards a customization of the different tools. And this is the main issue. It's like, for example, if you consider you want to ask an architect to build your house, but if he builds a house in which you are not happy, you're not happy to live, it means that the architect is a bad architect because he didn't consider your habits of living, he didn't consider your style or your taste of living, etc. So it's the same. We consider that it's not the same with virtual reality, where people who develop virtual reality technologies never consider the end user in the development of the technologies. So this is currently what happens. So in the real world, if you want to transfer real world kind of a navigation to virtual world navigation, there can happen immediately or very quickly a sensory conflict that leads to cyber sickness. The different navigation methods or the different devices are not very much intuitive and or necessitates training, so this leads to rejection of VR. And what we propose is not just to have a very simple communication between the human and the virtual environment, but to add this personalization or this customization of interaction in virtual worlds. That means that we need somehow to understand very well how a human acts, and this is what Christophe just mentioned just before. So here I want to introduce what we in the different works that we performed here in Arts in Chalon-sur-Saône, what we call the smart VR, which means putting some intelligence, but not intelligence necessarily in terms of AI, but also intelligence in how to use the different navigation method, interaction method that exist in the literature in a smarter way. That means that not just implementing and applying the method like this, but also considering that we could also intelligently use these different methods. So one example is adaptive navigation, what we call adaptive navigation based on cyber sickness indicators. Here the idea is very simple, because the idea here is to measure the level of cyber sickness encountered by the user while navigating, for example. So here we used electrodermal activity as a cyber sickness indicator, which is quite robust, and to measure in real time, so this activity, because we know that the EDA increases with cyber sickness, it has a temporal effect, And so the idea is to measure in real time the evolution of the EDA. So for example, here you have an example of someone navigating in a virtual environment, and you see that as long as he interacts, he navigates in the virtual world, his electrodermal activity is increasing little by little. And the idea, what we propose, is to use this parameter, this data, to propose something that leads to a very low EDA all the time. So on the right side, you see for the same person in the same environment, you see that his EDA has become very low. It's not because of learning effect. It's really because we consider in real time his physiological state to adapt the acceleration, navigation acceleration in the virtual world. So here you see the formula, which is very simple. It's just like, it looks like, for people who know a bit of mathematics, it looks like Euler integration. That means that you consider the acceleration in the previous frame, and you add the variation of the ADA between the previous frame and the current frame. And if the variation is positive, so it means that if the EDA increases, then it means that the participant, the user, is getting thicker, and so we decrease the acceleration, the maximum acceleration, so that the level of thickness can decrease by itself. And if the evolution of the EDA is negative, so if the level of cyber thickness decreases, then we can increase again a little bit the acceleration. And this is how, very simply, using just a joystick navigation, joystick-based navigation, so very simple navigation method, where we didn't develop a new method of navigation. We consider using a very classical navigation method, but just saying, okay, maybe we can be more intelligent in using this navigation technique. We observed that a significant decrease of level of cyber sickness without changing the performance on navigation. That means that the participants in our experiment who navigated using this adaptive navigation performed as good as people who did not have to this opportunity to have adaptive navigation. So no need to design new interfaces, no travel techniques, no change in the performance, just we focused on the user state in real time. So this is very interesting, but the problem is it reliable? Is it predictable? That means that, of course, if this methodology wants to be, if we want this methodology to work well, we have to let the user navigate a little bit in the virtual environment, because of course we don't know what his states at the beginning. So that means that this adaptation and navigation can take a little bit of time. So in terms of predictability, it's not very good. In terms of reliability, it is not perfect also, because the EDA is not the best choice, maybe, because there are some people, you can put a sensor watch on them. It will always output a 0 as electrodermal activity, because they never sweat or they don't have any specific electrodermal activity. So based on this, or what we did, we try to also use AI. We try to consider using AI tools and knowledge-based tools to develop two different methods. So two things: one, to better predict cyber sickness, so based on deep learning, for example. So this has been done by one of our PhD candidates, which allow to measure and to predict cyber sickness based on data that we collected from previous experiments. And we also consider using knowledge-based information from the different characteristics of the users. So for example, if we know the age of the person, if we know its gaming experience, if we know where he comes from, because we know that, for example, these parameters are important, can influence the susceptibility to cyber sickness. Then if we put a black box, implement a black box, let's say, in the venture environment that take all this data as an input and then at the end can provide what we called an individual sickness score or sickness severity score, so which is called here OFIS. So it's based on fuzzy logic or fuzzy logic coupled with neural networks. We can have so each user can have its own score, and with his own score, the system can adapt automatically the navigation or can adapt the interaction so that the user does not get sick. The only problem with AI, and this is, I think, the most important issue with AI, is the lack of data. We need to have data. So if we are used to make experiments, we can collect many data over many years. But if it's not the case, or if the data are not relevant to what we want to do, this is an issue. So what we think is also how we can create artificial data that can be relevant to our issue. So this is what I wanted to show to you. If you have some comments or if you have some thoughts or whatever, don't hesitate to ask. Do you have some questions, or everything is okay for you? In French, we usually say that who don't say any word agrees. So, but maybe you have some comments to make. If there is no other comment, we can probably also share with you some ideas or some next steps or some some other ideas that we have or that we may have to extend what we said just now. So I prepared another slide. No, that's this one. This one. So there is something also that is important, maybe, that it is not only important to to develop interaction as we do now, but it's also important to consider other parameters that can also enrich the immersive experience. So, for instance, the multi-sensory interaction. So I think for example, the haptic feedback is something very important to add in a virtual environment, because we don't rely in a real world only on our vision, but we also rely on haptics. We could also consider sound, because we know that sound is also a parameter that can help people getting more confident in the space. Smell also is something that so you know probably that there are some companies selling or developing smell diffusers to diffuse some fragrance to enrich also the immersive experience. So we could also consider using such sensory cue, but also taste, and so on. So we can imagine enriching immersive experience, not only considering vision, but also other sensory cues. So I think this is not enough developed currently in XR because most of the devices are relying on vision, then on haptics. So we know also that there are some people, some companies also developing haptic feedback systems, or like data gloves, or like haptic arms, haptic suits, and so on. But I think this modality is not yet fully or completely well integrated in XR. So I think we have still to work a lot on this sensory feedback and other sensory feedback that also would be interesting to consider.
Interrupt, Jean-Rémy. There's a question from Pallot in the private chat.
Oh, okay. I'm sorry, I don't see all the questions. But in the private chat. Oh, okay. Can you reiterate what would be the ideal mechanism for nausea detection in VR if hardware price was not an issue? Okay. For me, there are several ways to consider. So, if you look in literature, there are some people, for example, who do I don't remember how it's called. It's galvanic stimulation, something like that. So where you put you put an electrode, or you put a headset on your head, and you provide to the user an electric how do we say kind of electric shock that can also that was proved to be efficient against cyber sickness. But of course, for some reasons, for some ethical reasons, especially, there is no one in the market who sells such system for VR. So this is not maybe the best choice, but this is one idea. Another idea, and this is what we defend here, is to say we don't necessarily need to develop new hardware. Again, if we try to use what is already existing, and so not developing completely new hardware and new devices and so on, but just if we can use what is existing more intelligently, in a smarter way, maybe we can reduce significantly all the issues that are related to cyber sickness and so on. So this is what I tried to show in the previous slide, that we don't need necessarily to develop new things. We have many tools already existing, so mathematical tools, we have artificial intelligence tools, we have all the knowledge that was gained over decades about cyber sickness, for example, and so on. With all these tools, we can develop new ways to mitigate these effects, and not necessarily by developing new hardware. Okay, another way, maybe, Paolo, if you're interested, it's something a bit crazy, but it's just kind of, a very long-term issue, long-term vision, is what I call the subconscious interaction is exactly what is happening in Matrix, for example. If you remember Matrix, that was released more than 20 years ago now, you remember probably in the movie that the world where he is currently is not the real world, but a computer-generated world. And but he doesn't feel any problems being in this virtual world or this computer-generated world. And so the idea maybe would be, if it's possible, to achieve something like what happens in Matrix. That means, and the closest thing that is close to Matrix is the dream. Why? Because if you consider dreams, in dreams you don't, you can do many things, many activities. You can walk, you can run, you can jump, you can even do things that you would never do in the real world, like flying, for example, or whatever. And the good things with dreams is that as there is no sensory stimulation, you never get sick from your dream. So even if you walk in your dream, even if you don't move in your bed, you never get sick because there is no sensory stimulation. And the good thing also with dreams is that there are some people who showed that the level of energy that you spend in dreams is the same when you're dreaming as when you're awake. That means that if you run, for example, in the dream, you will spend the same amount of energy in your dream than if you are really running in the real life. So this is interesting because it means that without doing any effort, you can have the same amount of energy spent, which means that dreams are really allow you to have to be very immersed in your dreams. And another thing that is quite interesting, I think, is something that is called lucid dreams, where people show that if you train someone for a specific task, or for example to run the fastest as possible, if you train these people in a dream, not in a real life, but in a dream, the performance of this person will be at a minimum equal to the performance of someone who trained for real. That means that without moving from your bed, you can have a performance of a sprinter that is equal or even higher than someone who trained for real. And the good thing with lucid dreams is that everyone can learn quite easily to do lucid dreams. So it's a specific state of dreaming where you are aware that you are dreaming, but you're not awakened totally. And so if we combine all this, maybe what would be interesting to study is to transfer all this knowledge in dreams to VR, because somehow VR is also a dream if we extrapolate a little bit. That means that it's a virtual world, like in dreams. You perform actions in virtual world like you would do in dreams, for example. You are not limited by physical constraints, I mean in terms of physics or whatever. And so maybe we could explore dream mechanisms and apply what is existing in dreams, in the knowledge of dreams, to apply to VR, and maybe why not make VR more immersive. So the idea would be to allow if we, for example, we measure what's happening in the brain, we could, for example, try to do so that the response from the brain in VR be the same as in dreams. And if we succeed to do this, maybe fiber signals won't exist anymore. Because if in dreams it doesn't exist, why it should exist in VR? Okay, so maybe this is a little bit crazy, but why not? We could even go further beyond traditional, let's say traditional VR. Okay, I'm done. I saw, Pallot, that you were kind of amazed. We have some other comments. Don't hesitate to put your microphone to ask questions if you want to discuss. Okay, if there is no other questions, comments, or whatever, maybe we can stop here, I think. Already late. How does it work? Okay. Okay, so I think there is something in the program, but I don't know exactly what is the next in the program. What is next in the program? But if there is no other question, maybe thank you for attending, and I wish you a pleasant Laval virtual, and have a nice end of day.
Have a nice evening, everyone. So there's no other presentation in this room after you. So
yes,
let's go home.
Okay, let's go home.
Thank you. Bye.
Bye.